It's very hard to follow previous talk, so exciting. Let me bring you back to a very different topic about survival of human being in this world, on the carbon neutral economy transformation. So you have been seeing the climate change pattern, and about a month ago, less than a month ago, the COP26, the UN's climate conference, the commitment from each country to the carbon neutral economy, roughly about 2050. I would like to share with you the view of what's happening. First of all, there are large numbers. Many countries now committed to climate goal. Looking at Paris Agreement, looking at China, 2060, Russia, Saudi Arabia, and India. These are the biggest greenhouse gas emission countries, including US, of course. And 60% of Fortune 500 companies committed to climate goals. Some of them 2050, some of them 2040. For example, Amazon's climate pledge. So this is probably the biggest challenging problems human being is facing. It's about survival. With the climate change, with extreme weathers, whether it's California fire or the Texas extreme cold weather back in February, we are really facing big challenges. Stanford, at the bottom bullet right there, bullet point. Stanford is starting a new school on climate and sustainability. And you have to know Stanford has not started a new school for 70 years. This is first time in 70 years. Stanford contributed a lot to starting Silicon Valley, spin off so many companies. But Stanford has not started a new school in 70 years. This is first time. And this is present to you the challenges we want to overcome and the resources we want to put behind in order to solve this problem. So at Stanford, we have been having more than 200 faculty, close to 300 now, working together on science, engineering, economics, and policy to help fighting the climate change. For some of the people on the top row, top left hand side, probably look familiar to you, including previous cabinet member Condi Rice, Bill Perry, Steve Chu, and we are forming a very big team to fight against climate change. And the Precourt Institute for Energy is an organization at Stanford setting up about a decade ago to organize all our assets together across all the schools, from all the way to the lab engineering, to science, to business, to law school, with the new school starting all the way on the right. And we are trying to build up the expertise even more so. So to share with you, Stanford announced last year we will be starting a new school. This year, President of Stanford announced this blueprint. There will be close to 10 new departments to be set up. Those are the vertical column you see. And with the institute structure cross-cutting, Precourt Institute for Energy, Woods Institute for Environment, there will be institute on sustainable society to be set up, and plus sustainable accelerators. For many of you sitting right here, maybe the accelerator is a very exciting one because you want to see what's coming out of Stanford on sustainability space. And there will be new startup coming out, technology solution, policy solution, all come out. I want to share with you at the outset what's happening in the sustainability space at Stanford. Now let me really try to see, well, how do we really play this game? How do we really organize ourselves together to fight against climate change? Well, this is the pie chart on the greenhouse gas emission from different sectors. we organize our act together according to where the CO2 coming from, where the methane coming from. Electricity sector is very big, transportation is very big, industry, building, agriculture. So at Stanford right now, we are forming the whole ecosystem on the clean energy transformation. We have our Bits and Watts initiative is to decarbonize the electricity sector, the power grid. StorageX for storing energy, enabling electrical car, enabling grid-scale energy storage, letting more solar and wind electricity to be integrated into the electrical grid. And how do we utilize natural gas in a clean way, natural gas in the initiative? We have two fundamental centers on catalysis and materials funded by Department of Energy. We are also in the process of launching new initiative that's carbon removal, clean hydrogen, and sustainable manufacturing. In this process, we also recognize it's very important to have finance, economics to work out. We are having a sustainable finance initiative, policy, education, external communication, using data and AI to plan for the future energy systems, technology translation, social human behavior, and global engagement. So this is the whole ecosystem we set up to organize our faculties, our students, our partners, our alumni, and work with the whole world to help generating the solution to decarbonize the economy. Well, let me come to my own lab. 16 years at Stanford as a faculty, I have been working on nanotechnologies for sustainable transformation, including high energy density batteries. Can you increase the range of electrical car and further reduce the cost? I founded Amprius back more than a decade ago. And nanotechnology to help filter out the air, the pollutants, the particles. Turned out to be during COVID-19, our nanofiber technology generated the best facial mask at the N95 level with the best breathability. We've been selling this quite a bit online in California. So to accelerate the technology transformation, I also set up a technology accelerator just for sustainability, and use this accelerator company, just spin out Largescale energy storage company, EnerVenue. We announced a couple of months ago of raising $125 million Series A. This technology is really a breakthrough to help integrating solar and wind electricity into the grid in a very low cost, very long lifetime manner. We also launched recently our cooling and warming textile product that can cool the human body during the summertime, warming your body up during winter time, much more efficiently than anything you wear in the audience. And this will help saving the building energy consumption. So there will be more coming, water filtration, soil cleanup, and the green building materials. But let me highlight a few in terms of technical content. One is on the high energy density batteries. If you look at the market, you say, well, going from electronics, drone to electrical vehicles. Well, what's common? You need a power sources. When previous speakers showing you all these cool VR and AR, right, these devices. So remember that everything you wear so far require really big batteries right there, or wiring, plugging into the wall. Power is so important. I think without power, you will need to discount the metaverse by a lot without its power. So this is very important right there. So what's the market size? You are seeing the crazy growth of the battery industry driven by the electric car. Well, we have 1 billion cars running on the street. If they all become electrical in the future, this is passenger car, by the way. I don't count the 300 million bus in the truck yet. So 50 kilowatt hour of a battery pack right there. This is a huge battery production we need. And I assume very low cost, right? Range right now, $100 per kilowatt hour. You are talking about $5 trillion market. So every 10 years, you need to change battery at least. So on average, you are talking about $500 billion market per year. And we're still about 20 times, 30 times away to have this yearly production. So next 5 years, you are going to see the very significant growth of the battery production. By 2025, if you look at its production going up, it's at least 10x. Well, you need high energy density as well. We are roughly at about 250 watt per kilo. And can we double the amount of energy you store per weight or per volume of the batteries? This has huge meaning on the driving range, has huge meaning on the cost saving as well. So over the years, my lab working on, for close to 15, 16 years now, a new material is called silicon. It has 10 times higher capacity compared to graphite carbon. But it's very hard to make these new materials to work. Volume expansion is too big. Once you store lithium coming in, because materials breaking, instability of interface. So in order to make it to work, we have to utilize nanotechnology. Back in 2008, we published the first paper of generation 1. Until now, we think we really understand how the batteries work, how to enable these new materials. Now with Amprius, we are having a world highest energy density batteries now supplying to the drone, to Airbus, particularly the Cypher's drone, breaking the world record, 25 days of flying time without stopping. You have learned about solid-state batteries becoming hot. That's the next thing. Solid-state is not quite there yet, even though there's a lot of buzz around there. Everybody's talking about solid-state. Solid-state is still quite far away, and you need to face the reality. So let me share with you the second one, large-scale energy storage, to integrate solar and wind electricity into the grid. Large-scale energy storage has a many time scale from all the way lab to minutes to stabilize the grid, to hour, day to day, and then to seasonal. And the market needs is also very big. If you look at the world electricity consumption, 2018, I only consider storing 4 hours. I have not considered store for the whole day yet. This is the market size you are going to be seeing is $1 trillion right there. So what are the solutions for grid scale? You would like to have extremely long life, 30 years instead of 10. 10,000, maybe even 30,000 discharging cycle. Instead, only 3,000 you use in electric cars. You would like it to have a very low cost, very, very safe. Otherwise, you're going to have this huge battery right there catching fire. That would not work. This happened a lot already based on lithium ion. Then we say, what's the best chemistry available human being ever invented or about to invent? So several years ago, my lab demonstrated this nickel hydrogen gas, 0 accidents, used in aerospace for already over 30 years, 40 years. And Hubble telescope is using that for 30 years. Very reliable, 30 years lifetime, 50,000 cycles. But the cost was too high. We invented the new materials to replace the high cost component, yet maintaining the performance. So this is very exciting to me. I launched EnerVenue companies, and we just announced a $125 million Series A raise led by energy service companies, Schlumberger and Saudi Aramco, a very big oil company, and a number of investors as well. This gives you really amazing chemistry, and you can discharge, go down to minus 40 degrees Celsius. go up to plus 60 without air conditioning. So this is what lithium ions cannot do. I'm very excited about this, seeing our Inner station pretty soon will be deployed in the market. So in Fremont, California here, we are building our first factory. And within a couple of years, we'll expand to our gigafactories with this $125 million. Well, last, let me share with you cooling and warming textile. And there's really not that much invention going on in the textile industry. Well, once in a while you heard about one, right? You heard about maybe CoolMax, Omni Heat. And if you look at textile industry, don't neglect this industry. It's already $2.5 trillion per year industry. And our sleeping, our work spot, mobility, and home, we all utilize that. And because it's been too long, oftentimes people forget about what there could be a lot of innovation you could do. So we're coming in to do the innovation at Stanford is really try to save building energy consumption. 13% of energy every year is used in heating and cooling. We ask this question, well, if you can change your air conditioning set point by 3 degrees Celsius, you save 30% of energy used in cooling and heating. How do we do that? And you need to feel comfortable in the indoor environment. If you change the set point, summertime not so cool, wintertime not so warm. So we say, well, let's have a personal air conditioning. That's actually your clothing. Can we do much better and compared to the current clothing? And you can even use this in the car as well to save the car energy consumption. So let's reinvent the textile. Looking at how human body dissipates the heat, about 50% of your heat is dissipated by infrared radiation. That's why infrared camera can look at you. You have a temperature of 37 degrees Celsius and giving out the mid-infrared wavelength center around 10 micron in wavelength. So then we say, what we really want to have is summertime, a cooling textile that's transparent to your infrared. In the wintertime, keep all the heat to yourself. So we probably announced LifeLab Design. We launched 2021. We now have this commercial, launching the product right there, a warm life on the top row. It's very warm jacket. We actually released the most right-hand side called Mega Warm. This is the warmest jacket ever invented in human history. Much warmer than any other brand you see in the market. But its thickness is only half. Its weight is only half. We also have the Cool Life at the bottom right there. If it's summertime, you will have the motivation to wear that. I already wear that in the past summer. The feeling is sensational. And this type of cooling textile could be also used in your bedding materials, pillowcase. I've been trying that in the past summer, and your sleeping quality will be improved tremendously. So next summer, we'll be releasing a lot more cooling products. So this, we hope, will help saving the building energy consumption. Also, let you to go to a different environment and feel comfortable. And not only that, all the materials we make into this clothing and textile, our environmental index, right, sustainability index so low, that means it's a lot more sustainable without polluting environment. And we have multiple innovation going into this clothing, including even our tag. Now it's a QR code. We remove all the tagging. Every time you buy clothing, you need to remove so many tagging right there. We remove those completely. A QR code, a phone scan will allow you to see what's really in there. So with that, I want to emphasize, now we are facing the challenges of sustainability. How do you take a lab technology into the market? And I think for the GIFT conference right here, it's worth to consider. So through multiple of my setup, or my spin out, from my Stanford lab to the market. What you're seeing is, in terms of gram, in the lab, you're usually dealing with milligram. But in the commercial space, scalable space, you're talking about at least 1 million tons of materials. And with centimeter square to the lab to 1 billion meters square. So there's huge scaling you need to do. How do you do that? Right? There's also lab prototype to commercial prototype to manufacture product. There's so many things you need to debug, you need to solve. So what would be the best mechanism in doing that? And utilizing EEnotech in the past few years as a technology accelerator really build a common infrastructure. We feel like we finally have a mechanism taking a Stanford lab invention to the market. Just within several years, we cut the time by at least half, sometimes by about 60%. We also save the cost, cut it by at least half. So this will be a mechanism I will continue to use to help spinning out the technology from university lab. Now with Stanford's new school starting to set up the technology policy solution accelerators, I hope this will help us to speed up the technology translation and going to the real world. So with that, I will stop here. Thank you very much for your attention.